Welcome to this comprehensive guide on debugging and profiling tools in Visual Studio and Unity 3D, essential skills for any game developer. Debugging helps you identify and remove errors or bugs in your code, ensuring your game runs as intended. Profiling, on the other hand, measures your application's performance to pinpoint bottlenecks and optimize resource usage. Mastering both debugging and profiling is crucial for creating smooth, efficient, and enjoyable gaming experiences. Let's begin by understanding how to effectively debug your code within Visual Studio, a powerful IDE. First, ensure Visual Studio is correctly integrated with Unity. This usually involves installing the Game Development with Unity workload. Breakpoints are fundamental debugging tools. They pause your code execution at a specific line, allowing you to inspect its state. To set a breakpoint, simply click in the gray margin next to the line number in your code editor. Once execution is paused, you can step through your code line by line using commands like step over, step into, and step out. Step over executes the current line and moves to the next, treating function calls as a single step. Step into dives into the called function, allowing you to debug its internal logic. Step out executes the remainder of the current function and returns to the calling code. While paused, inspect variables using the watch window to monitor specific values, or the locals window for variables in the current scope. The call stack window reveals the sequence of function calls that led to the current execution point, invaluable for tracing program flow. For more advanced scenarios, conditional breakpoints only pause execution when a specified condition is met. This is incredibly useful for debugging loops or specific states that occur infrequently. Now, let's shift our focus to debugging within the Unity 3D engine itself. A quick and easy way to debug in Unity is by using Debug, log to print messages, warnings, or errors to the console window. For more in-depth debugging, you'll need to attach Visual Studio to the Unity editor. This allows you to use all the powerful Visual Studio debugging features directly with your running Unity game. Unity's console window is your primary hub for debug, log output, errors, and warnings generated by your game. You can filter messages by type and even click on them to jump directly to the relevant line of code. Visual debugging with gizmos and handles allows you to draw visual aids directly in the scene view. These are incredibly helpful for understanding object positions, movement paths, and interaction ranges. Now, let's delve into profiling, starting with Unity's built-in profiler. The Unity Profiler is a powerful tool for analyzing your game's performance in real time. It provides detailed insights into CPU, GPU, memory, rendering, physics, and audio usage. The CPU usage module shows how much time is spent on the main thread, render thread, in your scripts. Look for spikes in the main thread, which often indicate heavy script execution or garbage collection. The GPU usage module helps identify rendering bottlenecks, such as overdraw or complex shaders. High GPU usage might mean you have too many draw calls or your shaders are too computationally expensive. Memory usage tracks how much memory your game consumes, including textures, meshes, and audio assets. Excessive memory usage can lead to crashes or poor performance, especially on lower-end devices. The physics module details the performance cost of your physics simulations. If your game has many colliders or complex interactions, this module is crucial for optimization. Similarly, the audio module helps you monitor the performance impact of your sound effects and music. Identifying bottlenecks is the primary goal of profiling. Look for the largest spikes or consistently high values in any module. Once identified, you can then focus your optimization efforts on those specific areas. Visual Studio also offers its own set of profiling tools, particularly useful for deep dives into C# code performance. The CPU usage tool in Visual Studio can pinpoint which functions are consuming the most processing time. This is excellent for optimizing specific algorithms or complex calculations within your scripts. The memory usage tool helps track object allocations and garbage collection, crucial for preventing memory leaks. Understanding these tools will significantly enhance your ability to create high-performing games. Let's cover some best practices and helpful tips for both debugging and profiling. Firstly, start debugging and profiling early in your development cycle. Addressing issues early saves significant time and effort later on. Always use version control, like Git, to track your changes. This allows you to revert to previous working states if a new change introduces bugs. Keep your code clean and well-organized. Readable code is much easier to debug. Consistent naming conventions and modular design also contribute to clarity. Test frequently and systematically. Don't wait until the very end to test your game. Small, incremental tests help catch bugs before they become deeply embedded. A common pitfall is premature optimization. Don't optimize code that isn't a bottleneck. Use profilers to identify actual performance issues before spending time on unnecessary optimizations. Remember, debugging and profiling are iterative processes. You'll constantly be identifying issues, fixing them, and then reevaluating performance. By consistently applying these techniques, you'll build more robust and efficient games. Thank you for joining this guide on debugging and profiling in Visual Studio and Unity 3D. Keep practicing these skills, and you'll soon become a master of game development.